Okay, this is the example we didn't get to go over in class. We have a graph of systolic blood pressure by age, where the x-axis is the age of the person and the y-axis is the systolic blood pressure in millimeters of mercury. And systolic blood pressure is your blood pressure when your heart is beating, when your heart beats, and that's the top number of your blood pressure. The bottom number is your blood pressure between beats, just in case you wanted to know. And so we are seeing that as people age, their systolic blood pressure increases a little bit every year. So we are given 2 points. You can tell that, the points are data points, which means that they were collected from a person, in real time, in real life. And so therefore it doesn't actually make a straight line, but it's pretty close. So we're going to write a model for this behavior of blood pressure. And we're writing the equation of that line that's drawn there. Part A says, suppose that X represents the age of an adult in years and Y represents the systolic blood pressure in millimeters of mercury. Use the points 21, 118 and 51, 130 to write a linear model relating Y as a function of X. So you've got 2 points and you're going to write the equation of a line, so you have to find the slope. So to find the slope, you are going to subtract your Y coordinates and divide by the difference of your X coordinates. And when you do that here, you're going to have 12 over 30, which is 2/5. And so you know that the equation of your line is going to be Y equals 2/5 X plus B. Y equals MX plus B. And so to find B, we're going to plug in one of the points to that equation. So we'll put in 118 for Y and 21 for X. And then we will multiply and solve for B. And we will get that B is 109.6. So our equation, the model for this graph, is going to be Y equals 2/5 X plus 109.6. Part B says interpret the meaning of the slope in the context of this problem. Okay, well, if you look at the equation, you can see that 2/5 is being multiplied by the age of the person. And so every time X goes up by 1 year, 2/5 of a millimeter of mercury are added to that person's systolic blood pressure. So it's kind of the rate of change of a person's blood pressure as they age. So your systolic blood pressure goes up 2/5 of a millimeter of mercury each year. Okay, so part C says use the model to estimate the systolic blood pressure for a 55-year-old. So we're just going to plug that in for X into our equation. So Y equals 2/5 times 55 plus 109.6. And then we just multiply it out and we get 131.6. And they tell us to round to the nearest whole unit. So it would be 132 millimeters of mercury for a 55-year-old.